I'm Aliyah Benisarellano Abela, grade 8 Mahogany of Ramon National High School, Ramon District. Thanks be to God for giving me the opportunity to listen to the different episode of Radyo Eskwela. I find it hard to answer and understand my lesson, but with the help of Radyo Eskwela sa Isabela, I was able to finish my learning modules and other activities. I'm so thankful because I was able to make use my lessons through SDO Isabela's radio-based instruction. At sa Radyo Eskwela sa Isabela, patuloy ang edu-action.
Good morning, dear young scientists. You are listening to our School on Air science subject. I hope you fully understand our lesson for today.
SciTalks Radio. Education must continue.
Learning is a great avenue.
No one will be left behind. With new normal comes new learning.
New method, new way of understanding.
Keep on learning.
Keep on achieving.
There's no way of hindering.
Enriching one's dream.
This is SciTalks Radio, your number one source of science education. Conveying a half an hour of quality scientific teaching on air.
This is SciTalks Radio.
Good day to our beloved 9th grade students. This is your School on the Air. We are pleased to join you in your study through the line. I am radio teacher Raysper de Villa. Please make yourselves comfortable as you participate in our broadcast. Have you taken a meal already? We do hope so, as a sound mind makes a sound body. Keep yourself in tip-top condition so you may focus well on your topic and understand the lesson at hand. At this point, I want you to bring out your learning activity sheet for the lesson, Heat and Work. Set the pages of your 4th quarter module to page 72. Once again, our lesson is all about heat and work, and go to page 72 in your module. Alright, let's begin our lesson with a series of questions. State your answers based on your previous lessons. Are you ready? Let us commence. These will be easy, barely an inconvenience. What is the difference between potential energy and kinetic energy? Exactly. Simply put, potential energy is commonly defined as stored energy, while kinetic energy is known as energy in moving matter or wave. Next question. What do you notice when kinetic energy is used to transform into mechanical energy, such as riding a bike? Indeed, not only that there is work involved by using energy to move yourself and the bike from one place to another, but also you may notice that you feel hot due to cycling and even the parts of the bike. Which parts of the bike would most likely be a bit hot after several minutes of biking? Very good. The parts of the bike that is most likely a bit hot would be where motion happened most, like in the crank, tires, and the hub. Is heat the same as temperature? Does a moving bike gain heat or release heat during work? How is heat converted to work? How is work related to energy? All of those will be answered as we progress in our lesson. Whenever you might hear the term heat, you might think it as synonymous to temperature. This is inaccurate. Heat is actually the transfer or flow of energy from one place of high concentration of said energy to places of lower concentration. To make it easier to understand, heat is like a powdered juice concentrate poured into a clear pitcher of water. If you have observed it already even without stirring it, the juice particles would move into places in the water that is clear until the whole pitcher becomes colored by the juice powder. In the case of heat, it is not a particle, but a form of kinetic energy as the very small moving and excited atoms collide with the non-moving atoms like hungry students in a line pushing one another during a busy recess in the canteen. On the other hand, temperature is a measure of the presence of how much heat is present in an object or space. When asked by your mother or father to cook rice, of course you would put water and rice in a pot, and then put the pot into a stove. Set a flame. How does the heat from a fire transfer into the rice? Well done! In this situation, heat flows from hot burner to the initially cold rice and water. When two objects at different temperatures are put in contact, heat spontaneously flows from an object of high temperature to the object of low temperature. Take for an example, whenever you're making a hot cup of coffee or chocolate drink in the morning. Using a cold or even a room temperature metal spoon, you might notice it gets warmer as the spoon remains in contact with the hot drink. Why do you think it behaves this way? Absolutely, it is because the natural flow of heat is always in the direction tending to equalize the temperature. Simply put, heat energy will always go where there is little or no presence of heat. In certain instances, if two bodies of different temperatures are kept in contact for long enough, their temperatures will later on become equal. Take a peek on your modules. What do we call this state? That's right, we call this state as thermal equilibrium. This indicates that when bodies are at thermal equilibrium, their temperatures would be equal and no more heat flow occurs. The best example for this is when you've had a fever. How do you take your temperature with a thermometer during a sick day? Exactly. You put the thermometer in your armpit and wait. Heat is flowing from your armpit to the thermometer. When the temperature reading stops increasing, the thermometer is then in equilibrium with your armpit, and they are at the same temperature. In your grade 7 days, you have learned that heat is related to temperature. Heat transfer may change one's temperature or one's phase, like how liquid water when boiled turns into steam, which is gaseous in nature. This change in temperature, either a decrease or an increase, means that there is an energy transfer in the form of heat. On the other hand, phase change means that there is a change in body's internal energy. We will be focusing only on the adiabatic, or when no heat enters nor leaves the system. Let's recall, learners, once again, what is the conservation of energy? If your answer is that energy cannot be created or destroyed, you are absolutely right. The first law of thermodynamics is actually based on this concept. As you can see on page 72, it is stated that the change in the internal energy of a system equals the difference between the heat taken in by the system and the work done by the system. Referred in the statement is a form of energy called internal energy. This energy of a substance is the totality of all the kinetic energy done by every molecule of a certain object. It can also be the molecular potential energy due to forces that act between the atoms of a molecule and between the molecules. Back to our discussion a while ago about jogging or cycling. What do you feel after an intensive session of such exercise? Quite perceptive of you. You feel a slight chill due to the air around you absorbing your body heat as your sweat evaporates. What does this mean? Did you absorb heat? Or did you release it? Well said! You have released heat that your body generated into the relatively cooler air. That explains why heat flows in instances where the work done is negligible. The internal energy of the hot substance decreases and the internal energy of the cold substance increases. Be reminded that while heat may originate in the internal energy supply of a substance, it is not correct to say that a substance contains heat. Think about it. Various internal processes like digestion or movement of blood inside you are all attributed to your molecular internal energy. As energy is used to move molecules within you, high temperature energy is released into relatively cooler surroundings. Yes, what is referred to in this energy transfer? Now you're getting it. It is heat. Remember, the word heat is used only when referring to the energy actually in transit from hot to cold. For better understanding of this concept, let's look into the equation featured still in page 72. The law is expressed as delta U equals Q minus W. Delta U refers to the change in a system's internal energy. Q represents the amount of heat flowing into a system during a given process, while W refers to the net work done by the system. To sum this equation, the total amount of final internal energy is equivalent to the difference between heat flowing in a system and the work done by the system. Based on this equation, how would the equation explain the relationship between heat and work? That's precisely the point. The first law tells us that a system's internal energy can be changed by transferring energy by either work, heat, or a combination of the two. This means that the increase in internal energy of a system is equal to the amount of heat added to a system minus the work done by the system. However, when there is a process that there is no gain nor loss of heat, this is called adiabatic process. In the past episodes, what is the SI unit of energy that we should use? You remembered. That's good. Use Joule or J as our SI unit for energy. Let's try a sample problem on page 73 of your modules. Are you ready? Very well, let's begin. If 150 joules of energy is added to a system when no external work was done, by how much will the thermal energy of the system raise? Since the given units are 150 joules of energy, represents internal energy or Q, and with no external work was done, W would be equivalent to 0. The question stands to ask for the value of the thermal energy, also known as heat. Heat in the equation a while ago is represented by U. Using the simple operation of subtraction, you subtract the value of Q, which is 150 joules, to the value of W, which is 0. Predictably, the answer is still 150 joules. The thermal energy received most of its energy from its internal energy with no work. This is the reason why you must unplug appliances when not in use, because they are not doing any work. Most of its internal energy turns into heat, which may cause fires. Have you ever wondered why the back of a refrigerator or an air conditioning unit is very hot? And in the sense of heat, which should travel from places of high temperature to places of lower temperature, the process of refrigeration is the exact opposite. The mechanism of air conditioners and refrigerators to make low temperatures is that they use a fluid inside these machines called a refrigerant that change phase from liquid to gas. This allows the fluid to absorb heat inside the machine and thereby cooling anything within. Now, what happened to the absorbed heat? Very good! That explains why the exhausts at the backs of these machines are hot, because the heat absorbed by refrigerants are released into the outside. We call these machines as heat pumps. These are devices that allow heat to transfer from a cold reservoir to a warmer one, which cannot happen spontaneously or on its own. Work is required for the heat to flow from a lower to a higher temperature. This work is provided by the motor of a heat pump. We all know heat flows normally from higher temperature to lower temperature. It is a natural or a spontaneous process that does not need energy to occur. However, in refrigerators, this is utterly defied. It is called a non-spontaneous process. In so doing, it requires mechanical energy and work should be done. Can you tell me, what law of physics is applied here based on your modules in page 73? If your answer is the second law of thermodynamics, you're definitely correct. It states that heat will never by itself flow from a cold temperature to a hot temperature object. The work is provided by the motor of the heat pump to reverse such process. To determine how much you've learned today, let's have a quick multiple choice quiz. Kindly bring out your quiz notebook in science and don't forget to inscribe your name, grade level, section, and the date today. Now, set aside your notes and modules and write your answers in your quiz notebook. Are we ready? Let's begin. For item number 1, while a gas does 400 joules of work on its surroundings, 900 joules of heat is added to the gas. What is the change in the internal energy of the gas? A. 500 joules. B. 400 joules. C. 900 joules. And D. 300 joules. Again, for item number 1, while the gas does 400 joules of work on its surroundings, 900 joules of heat is added to the gas. What is the change in the internal energy of the gas? A. 500 joules. B. 400 joules. C. 900 joules. And D. 300 joules. Number 2. Which of the following events is a non-spontaneous process? A. Drying of leaves. B. Spoilage of food. C. Waterfalls. D. Ice refrigeration. For number 2, again, which of the following events is a non-spontaneous process? A. Drying of leaves. B. Spoilage of food. C. Waterfalls. D. Ice refrigeration. For item number 3, which of the following laws of physics state that thermal energy will always equilibrate itself so that the temperature between systems balances out and become the same? A. Law of conservation of energy. B. First law of thermodynamics. C. Second law of thermodynamics. And D. Law of conservation of mass. Once again, for item number 3, which of the following laws of physics state that thermal energy will always equilibrate itself so that the temperature between systems balances out and become the same? A. Law of conservation of energy. B. First law of thermodynamics. C. Second law of thermodynamics. And D. Law of conservation of mass. For item number 4, what is it called when there is no transfer of heat happening in a given process? A. Adiabatic. B. Isobaric. C. Isochoric. And D. Isothermal. Once again, for item number 4, what is it called when there is no transfer of heat happening in a given process? A. Adiabatic. B. Isobaric. C. Isochoric. And D. Isothermal. Finally, item number 5. How does a refrigerator work? A. It works by utilizing perpetual ice gathered from the Arctic. B. It works by forcing heat within the system to a relatively hot environment. C. It works by absorbing the cold outside the fridge and puts it inside. And D. None of the above. Once again, for item number 5. How does a refrigerator work? A. It works by utilizing perpetual ice gathered from the Arctic. B. It works by forcing heat within the system to a relatively hot environment. C. It works by absorbing the cold outside the fridge and puts it inside. And D. None of the above. Now, Let's check your answers. For item number 1, 900 joules minus 400 joules, the answer would be letter A, 500 joules. Check if correct. For item number 2, the answer is D. Mark it with a check if it's correct. Item number 3, the answer is B, First Law of Thermodynamics. Check if correct. Next, for item number 4, the answer is A, adiabatic. Check. And lastly, item number 5, the answer is B, check if correct. Sum up with the answers: 1A, 2D, 3B, 4A, and finally 5B. Did you get a perfect score? My congratulations to you then. If not, don't worry, I know you can do better. Please do review your module once again in your spare time. We are done now with yet another lesson, and thank you very much for your excellent participation to our broadcast. I am looking forward to our next session. Make sure to regularly tune in here at School on the Air. On behalf of the pen behind the script and the SEO Isabela RBI production, we thank you for listening. Till next time, folks, I'm your science teacher for today, Ray Sperdevilla, saying, only true great heat is a strong sword forged. Good day and God bless.
Henerasyon sa daan ng pagkatuto ay walang maiiwan. Kaya halina sa Radyo Eskwela.
Patuloy ang edukasyon para sa ating henerasyon.
Sa daan ng pagkatuto ay walang may iwan.
Kaya halina sa Radyo Eskwela.